Okay, so today we're going to go into our next topic in Chapter 5. Now we're going to skip over Section 5.3 for now. We're going to come back to that a little bit later. But we're going to go to another point where we're talking about different types of triangles and different properties and theorems that go along with those before we get into the main topic, which is those congruent triangles, so writing the proofs and things like that. So today we're going to talk about isosceles and equilateral triangles. Now these are the types of triangles we talked about back in the first section when we were trying to classify triangles according to their sides. So remember, isosceles meant two congruent sides, equilateral meant all three sides the same. So now we're going to talk a little bit more about those types of triangles and what else we're able to say involving them. So before we get into that, there's one term we need to talk about, and that's this idea of opposite. So in geometry, when we talk about opposite, what we're talking about is across from. So what we mean by that is, like, if I'm looking at angle A right here in the picture, if I want to know what's opposite from angle A, I draw a line straight across my figure and I go to side BC. So angle A is opposite from line segment BC. Or if we start at a line segment, so like in this case I said, if we start at line segment AB, so if I start right here, when I draw a line across the figure, so if I go straight across to the opposite figure, I end up at angle C. So when we're talking about opposite within a triangle, we're talking about which side is across from which angle and which angle is across from which side. So you're going to see that term opposite used quite a bit within the different problems that we're going to see here. So as far as isosceles triangles go, we know from previous discussions that isosceles triangles have two congruent sides. Those two congruent sides are called the legs. And so this terminology is something you're going to need to know. So when they describe triangles to you in the homework or on a quiz or test, you know which part of the triangle they're talking about or which part of the triangle you're trying to solve for and things of that nature. So the two congruent sides, whatever two sides are marked congruent, are going to be considered the legs of the triangle. So within that isosceles triangle, the legs are the congruents. Now the side that is not congruent, so the non-congruent side of your triangle is going to be called the base. So every isosceles triangle has two legs and a base. Now that base does not have to be the bottom of the triangle. So if I were to draw an isosceles triangle this way, where these two sides are congruent, that means this is a leg, my base is actually the top. So don't get caught up with base having to be the bottom of a figure. We're talking about the non-congruent side in the triangle. Now, as far as angles go, there are two angles along each base, which we call base angles. So these two angles along the base of the triangle are going to be the base angles. So in that other triangle that I drew here, my base angles would be the two along the top there. So whatever two angles touch the base, those are considered base angles. The angle that's across from the base, so this angle up here in between the two congruent sides, is called the vertex angle. So that's the standalone angle within the triangle. So it's the one that's not along the base. And so again, you're going to need to know these terms so that when you're looking at questions or you're looking at homework problems and things like that, you know when they're describing the triangle which pieces they're talking about. So when they say base angles, you know where that is on the picture. When they say legs, you know where that goes. So make sure you know these different terms and what they stand for within the given triangle. Now with that, when we talk about isosceles triangles, what's special about isosceles? So two of the sides are congruent, but not only that, this base angles theorem tells us that if there's two sides that are congruent, then the angles opposite those two sides must also be congruent. So when I look at this isosceles triangle down here, these two sides are congruent to each other. So those would be the legs of my isosceles triangle. Now what this is telling me then is the angles across from, so opposite, must be exactly the same. And so these are the two sides that I circled are my legs. That means this right here is my base. That means each of these angles here and here are my base angles. So within any isosceles triangle, the base angles will always be congruent. So now I could say 3x plus 22 is equal to 2x plus 40 because those two angles have to be identical, and that's because they're across from or opposite from the two congruent sides, the legs. So then I can solve from here, subtract the 2x over, I get x, subtract 22 to the other side and get 18, and I found my value of x. If I were to plug x back in, 2 times 18 is 36 plus 40 is 76. And if I plug it into the other side, 3 times 18 is 54 plus 22 is 76. So I see that if I plug x back in, those two angles come out to be exactly what we want. Okay. Now the converse of the base angles theorem is also true, meaning if they tell me two angles are congruent, so here I've got this angle and this angle are the same, so within this triangle, the sides across from, so the sides opposite those angles must be identical. So that means this side and this side must be congruent. So basically within any triangle, if two sides are congruent, then two of the angles have to be congruent. If two angles are congruent, two sides have to be congruent. So then again, I just set up an equation to solve for x. 3x minus 6 equals x plus 10. And then I would solve for x, and if I needed to, I could plug it back in and show that those two sides are the same. But you guys are able to solve equations, so I'll let you kind of finish that one out. But make sure when you look at a triangle, if there's two angles that are the same, two sides will also be the same. So then one of the things we're going to ask you to do besides solving for missing sides or solving for x is being able to identify which pieces are the same based on what they give you. So for this one, there's two problems. The first one says if line segment HG is congruent to line segment HK. So they're saying in this picture, HG and HK are congruent. So if I mark those two sides, they want to know which two angles in the picture have to be congruent. Well, so if those are my two sides that are congruent, I go to the opposite angles. And so for this first angle right here, that's the only angle at that point, so I'm just going to call it angle G. Now when I go to name the second angle, I got to be careful because I have more than one angle at K, so I can't just say angle K. And so what I have to do is I have to make sure that I list the 3 points that make that specific angle here. So that's going to be angle HKG. So angle G will be congruent to angle HKG because those two sides, HG and HK, were congruent. Okay. Now in the second problem, so if we look at the second problem here, it says if angle KHJ, so KHJ would be this angle right here, and angle KJH, so KJH would be this angle right here. When I look at those two angles, if those are the same, it wants to know which two sides must also be the same. So if I were to follow those angles across the triangle, I get these two sides where my arrows are pointing. So one side would be line segment HK, and the other side would be line segment JK. So because those two angles were congruent, those two sides must also be congruent. And so it works both ways. Sides lead to angles, angles lead to sides. Same thing here, just a little more complex picture. So if they tell me that, for instance, line segment NL is congruent to line segment SL. So NL in this picture is this line right here, and that's congruent to this line segment here, SL. They want to know which angles have to be congruent because of that. So again, as far as those congruent sides are concerned, I draw arrows across my triangle. So here I'm talking about this triangle right here. So I'm restricting myself to right here. And so if I go across, I get one angle of angle 5, which must be congruent to the other angle that's across, which is angle 11. So because NL was congruent to SL, angle 5 must be congruent to angle 11. Okay. With that then, we can move to the next problem, which says angle 1 is congruent to angle 4. So now if angle 1 is congruent to angle 4, so first thing, if I'm looking at those two angles, that means I'm looking at this triangle here highlighted in pink. So if I want to know which sides are congruent because of that, so if angle 1 and angle 4 are the same, if I go across from each of those angles, so I draw my arrows across the picture, angle 1 leads to line ML, and angle 4 leads to line NM. So then line ML must be congruent to line NM because angle 1 and angle 4 were congruent. And so then we can go to the last problem, which is angle 9 and angle 10. Now for angle 9 and angle 10, if I mark those angles, here we got to be careful because what a lot of times kids will want to do is they will say, okay, well, angle 9 goes over to this side and angle 10 goes over to this side. But those sides have nothing to do with those two angles together, 9 and 10. What we're actually talking about here is with 9 and 10, those are part of larger sides. So if I highlight the sides they're part of, I actually end up with this big overall triangle. So when I'm looking at 9 and 10, I need to focus on the big overall triangle here. And so when I go across from angle 10, I've got to go across to this whole side here, which is line segment MR. And then if I'm going to go across from angle 9, I got to come over to this entire side over here, which is line segment MT. So if they tell me 9 and 10 are congruent, that means line MR is congruent to line MT. So it's really important that you make sure you go across to the opposite side or go across to the opposite angle for any of those two congruent sides. Okay. One of the last things here, the corollary, that just means a follow-up to a theorem. So the corollary to base angles theorem, so if two sides were congruent, then two angles were congruent. Well, what that also means then, if all three sides of a triangle are congruent, then that means all three angles must be congruent. So if the triangle is equilateral, then by default, it must also be equiangular, meaning it's always got to be the same three angles. So as we're looking at this, both things lead to the other. If all three sides are the same, all three angles must be the same. If all three angles are the same, all three sides must be the same. And as we discussed in a previous section, if it's equiangular, that means each of these angles has to be 60 degrees. That's going to be something that plays a major role in some of the problems you're going to see in the homework and on the quizzes and tests. So it's important to remember with equilateral triangles, all three angles are the same. And on top of that, all three angles have to be exactly 60 degrees. So the measure of angle A, for instance, has to be 60 degrees. Okay. Now, how can we use this theorem? Again, just like with most of the things that we learn, we're going to use them to solve for missing pieces, so either missing sides or missing angles. So in the figure below here, they want us to find the values of x and y. Now, if I look at this picture, one of the first things I should note is that they've marked some angles congruent. And so notice that in this triangle on the left side here, they've told us that all three angles are exactly the same. Well, on that last slide, we just learned that if all three angles are the same, then all three sides must be the same, which means this side NL has to be 4, and this side KN must equal 4, which means Y has to equal 4. So that's just knowing that the equiangular triangle is also equilateral, so all three sides have to be identical. Now, the other thing to take note of here is that they also tell us this angle LNM is congruent to this angle M over here on the right. And so for this triangle, what that tells us is that if I go across my figure, this side and this side must be identical. And we said this side had a length of 4. So this side and this side must be the same, which means I can take x plus 1 and set it equal to 4, which means when I solve for x, I get a value of 3. So within these pictures, what you got to look for is what types of angles are congruent, what types of sides are congruent, and then follow those across to their opposite pieces. So they started off giving us 3 angles, which led to 3 sides that are the same. And then we saw 2 other angles that were congruent, which led to 2 more sides being the same. And then it's just a matter of setting up equations and solving. So with that, you should be able to work on the worksheet from today. So you can get that from class, or you can get that off of Google Classroom. As you're working, if you have questions, like always, ask in class, email, or check the answer key when it becomes available. But everything should be following pretty simple or pretty close to what we saw in the notes here.